is a process in which subgroups are selected so that inferences can be made about the entire population. So instead of like polling the entire United States about like how they're going to vote, they'll only pull a select group. And so usually what they try and do is they try and sample based on certain characteristics, whether it be like age, sex, things like that. And so anyway, a sampling distribution is a distribution of the means of random samples of a certain size that are taken from a population. Okay, and so that's kind of what we're going to be talking about today. And so this is a formula you need to get down. This is the standard error of the mean. The standard error of the mean is the standard deviation of all of the sample means. Okay, and so the whole deal with today is what is known as the central limit theorem. So down there below, the central limit theorem states that as the sampling size n increases, the shape of the distribution of the sample means of a population will approach a normal distribution. So what they're saying is the bigger the sample, the more it's going to look like a normal distribution. Okay? The distribution will have mean, mu, and standard deviation, sigma divided by the square root of n. Okay? The z-value of a sample mean, we've already talked about z-values, it's the same thing, except for x bar is now the sample mean. That's the only thing that's different. Okay? X bar is the sample mean. Alrighty, so now what we're going to do is we're going to go ahead and get going with a few examples. And so this one says, according to a recent study, the average age that an American adult leaves home is 26 years old. Assume that this variable is normally distributed with a standard deviation of 2.4 years. If a random sample of 20 adults is selected, find the probability that the mean age the participants left home is greater than 25 years old. So what we need to do is find our z-value. Okay, the thing that we're focusing on right now is we're focusing on this. Greater than 25 years old. So how would I find the z-value? Close. Okay, z-value here is going to deal with the 25. So 25 minus 26 divided by the standard deviation, which in this case is 2.4. So let's go ahead and calculate that. What is 25 minus 26 divided by 2.54? Okay, now, realistically, that would be what we would do. The problem is that this is a random sample of 20 adults. So instead of dividing by 2.4, we have to take that into account. Okay, and so what we're going to do now is, if you remember from the slide before, it said that the standard deviation equals the population standard deviation divided by the square root of n. And so what we need to do is account for that first. So what is the standard deviation going to be? You already said it was 2.4. What am I going to divide by? Square root of 20. So my new standard deviation, and actually the one that I'm going to use in this problem, is going to be what? 0.5. Let's go to 4. 5, 4, 3, 6, 7. So 5, 4, 3, 7? 5, 3, 6, 7. Okay. So that's going to be what I put here. Okay. So now divide it out, and let's go ahead and use that. First step just what step? No. Yep, no, we needed to replace it with the 0.5367. Now, what I was saying is before that point, if you didn't catch, the question was, did we need to put the 2.4 in? And the answer is no. In a normal problem, you would, but this is a different problem than we've looked at because it has random sample. So whenever it has a random sample, you're going to have to do this step right here. Okay, and then that's going to replace what the standard deviation is. So, what did you get z to equal? Negative 1.863. So that's what my z-value is. Now, if I look in the problem, it said greater than 25. So here's my nifty little normal distribution. Okay, here is my mean. And if it says it's greater than 25, what side do I shade? To the right, right? So I need to go ahead and use my normal CDF function. So you're going to go ahead and do your normal CDF. What are my limits going to be? Yep, negative 1.863 and then what? E99. Okay, so go ahead and do that normal CDF, negative 1.863 E99. What'd you get? 0.9688. Okay, so they asked me find the probability, so 0.9688 would work. Otherwise, you could answer as 96.88%. Okay. So biggest thing, what you got to do here is you've got to account for the 20. Make sure you do that. Okay, let's look at the next one. It says the average number of tornadoes in Kansas is 47 per year with a standard deviation of approximately 14.2 tornadoes. If a random sample of 15 years is selected, find the probability that the mean number of tornadoes is less than 50. So normally we would go ahead and set our z-value, and in this case our z-value would be 50 minus 47 divided by 14.2, but I have to find my standard deviation here because it's a random sample of 15 years. So what am I going to do? 14.2 divided by square root of 15. Good. What is 14.2 divided by root of 15? 3.6664. So that's what I'm going to go ahead and plug in. 3.6664. Okay? What z-value do you get? 0.818. So now let's think about that. It says less than 50. So you have your normal distribution here. 0.818 is roughly here. And less than means which way are you going to shade? Left. So you're going to go ahead and do your normal CDF. Okay, I'm going to go ahead and do normal CDF on your calculator. What are my limits going to be? Negative E99, good. 0.818. Okay, so when you do the negative E99 to 0.818, what'd you get? Point what? 0.7933. And they asked us to find the probability, so we're set. Alrighty, pretty straightforward. Okay, let's go ahead and see what we got on this one. According to a recent study, wow, that should be study. According to a recent study, the average class size in high school nationwide is 24.7 students per class. Assume that the distribution is normal with a standard deviation of 2.5 students. Find the probability that a randomly selected class will have fewer than 23 students. What am I going to do here? Yep, equals. Yep. Okay, why don't I have to do the step that I just got to doing? It's not a sample. Whenever you have to do a sample, that's when you have to account for that. And so let's go ahead and look at this. What does this come out to be? Okay, so let's go ahead and look at the problem. It says we'll have fewer than 23 students. So you've got your normal distribution here. Negative 0.68 here. Fewer than means you're going to shade this way. Okay. So you're going to go ahead and do your normal CDF. Negative E99 to negative 0.68. And what did you get your probability to be? 0.2. Somebody else get that? So 0.2483 is going to be our probability. Alrighty, let's look at the next question then, because we actually have another question that's a takeoff of this one. If a sample of 15 classes is selected, find the probability that the mean of the sample will be fewer than 23 students per class. So in this case, you've got to do your z-value again. Okay, I've got my 23 students. I'm going to subtract it off of the mean. Does anybody remember what the mean was in the problem? 24.7. And in this case is when I'm going to have to do my sigma. Sigma in this case will equal the standard deviation, which is 3.6 students. And what am I going to divide by? Root 15. Good. So I'm going to take my 3.6 and divide it by root 15, in which case, what do I get? 0.9295. Okay, so that's what I'm going to divide by here. So what's my z value going to be? Okay, so in this case it says fewer than 23. So fewer than 23 means you're going to use your normal CDF. Negative E99 to negative 1.829. What do you get that to be? Okay, now let's compare the two. This one I took a random sample. That one I didn't. So look at how it adjusts the answers. Okay, by taking that random sample, what I did is I decreased my probability from about 25%. Oops, I decreased my probability from 25% to about 3%. So does the sampling affect things? You bet it does. Okay, so we've got one more example and then we're going to be done for today. This is going to be a two-parter as well. Consumers in the U.S. eat an average of 19 pounds of apples per year. Okay, 19 pounds. Assume that the standard deviation is 4 pounds and the distribution is approximately normal. Find the probability that a randomly selected person consumes more than 21 pounds of apples per year. So what am I going to do? 21 minus 19 over 4, which comes out to be 0.5, yep. So let's go ahead and do our normal CDF. Now notice this says more than 21 pounds. So when I do more than 21 pounds, what's that going to affect on my normal CDF? Right, what I'm going to do is I'm going to do 0.5 to E99. 0.3085, so 30%. You got a probability that 30%, if you randomly select somebody, you got a 30% chance that they're going to eat more than 21 pounds of apples a year. Now let's see what the sampling is going to do. Okay, the sampling says if a sample of 30 people is selected, find the probability that the mean of the sample would be more than 21 pounds of apples per year. So z equals, in this case, 21 minus 19, all divided by something that I need to find first. So sigma is going to equal, in this case, 4 divided by root 30. What is 4 divided by root 30? 7303. Okay, so in this case, I'm going to get 2 divided by 0.7303. 2.739. Okay, so I'm going to go ahead and do normal CDF on this one. Normal CDF, since it says more than, you're going to do normal CDF. 2.739 E99. What do you get? Okay. So yeah, not very much. Okay, so the sample affects a big chunk. Okay, so anyway, this is what you need to do. Oops, sorry, I skipped by it. Let's go back. Page 692, 1 through 6. You should have all the tools necessary to get this. Now, a little bit about how things are going to be. On Monday, I'm going to need this assignment. Okay, I'm going to need this assignment. What we're going to go ahead and do between now and Monday, okay, I'm going to go on with the lesson on confidence intervals on Monday. Okay, so we need to go ahead and be ready to do that on Monday. Those of you that are in 7th period, hopefully I'll be here Monday. If not, then we'll just adjust. You might have to watch a video again. Okay, but I will be here definitely for fourth period on Monday. I will not be here Tuesday and Wednesday of next week. Okay, and I know we have band people on Friday, so we'll make some adjustments, but we've got to start setting your schedule, and you might have to be watching some videos to get all this stuff done. So.